Thank you. Uh, Firstly, I wish to thank the organizers um, for this inviting me for this conference to share some of the things I have learned. Um, I have been in the construction chemicals application for various type of problems, issues, and all that for the past 40 plus years. I'm still active, though I'm retired. I have been working as a consultant to the company, and I'm still doing it. Where is the slide? Oh, here. Can I switch on the slide? So, my topic that has been given to me is to talk about something on fiber reinforced concrete, aggregate screed, hardness screed, and so on. All the cementitious things. We are going to talk about it. Now, why we need to use all that? Because if the floor is damaged, lot of strain in cleaning, damage to vehicles. There's a classic case. You would have heard of one company called Sylvania Lakshman, which used to make tube lights. There was I don't know whether it's still there, Sylvania Lakshman tube lights. So in one of their plants, the forklift was carrying all the packed tube lights, and there was a lot of potholes. The driver was carefully going, but some pothole he was not careful. Many tube lights fell from the forklift and they broke. It happened. Nowadays, recently, which is that car, the Toyota car company in Bangalore, one of the reasons they want floors to be smooth and all that, because the drivers are complaining about backache, forklift drivers. Said because we keep driving the forklift, that jump and bump and all that is causing serious back issues, and they're taking health leave and all that. It has become an issue there. So all those industrialists here and consultants, they may please take note of it. Floor has got a lot more to do. We don't want to give backache to our forklift drivers. Right. Another thing I forgot. I showed one red ring. The tires get damaged. Forklift tires wear out more when the floor is uneven. So, which is that steel plant, Udhaaharan steel plant. In their plate mill section, they have got very special forklifts, very tough, hard tires. Each tire costs 17 lakhs rupees, imported from Germany. One tire costs 17 lakhs rupees. And because the floor is damaged, the tire is getting damaged. And it is proving to be very expensive for them. Okay, so that's why I showed that red line. Okay, most of us know VDF floors. As somebody was saying, there was a practice whenever concrete is laid, VDF, vacuum dewatering, is done. And why VDF came into picture? It is about 100 years old technology, not new. Because when the concrete floor is laid for workability and all that, concrete floor, they used to use more water. Cement requires only 0.3837 water cement ratio for complete hydration. But only 0.3738 water cement ratio concrete is stiff. When this VDF came into the market, there was no technology of super plasticizer or plasticizer in the market. Admixture technology had not grown. So VDF came into picture. So what they were doing, because the water mix was high, they used to suck away the water. Why? Because more water was used for workability, but more the water, strength will drop, and floor strength we cannot afford to lose the strength on the floor. So vacuum dewater, suck away the water. So the water cement ratio will come down and you have got a strong floor. That's how VDF came into picture. What is the risk involved? Excessive suction. there are formulae that if you use so much water cement ratio, you should run the vacuum for so much. If the concrete is so much thick, you use so much water cement ratio, you should run the vacuum for so much time. There's some formula, okay? But 90% of the VDF installers, they are not aware of it. Many of them don't follow it correctly. What is the result? They suck away more water. There is no water left for hydration of the cement, and the concrete becomes very weak. In Bangalore, many of you have gone to that Koramangala, there is a Forum Mall. In the Forum Mall basement, parking lot basement, they had a serious issue when it was under construction. I mean, they called me, floor is getting damaged. I went and checked. At that time, one contractor's manager, he came in the bullet motorcycle. When he came, the tire print happened on the concrete floor. I'm not exaggerating. The tire, concrete got like clay. It was so soft. Why? Because the vacuum dewatering operator, it happened in the night, he went to sleep. And it went on sucking for how long, I don't know, God knows. And there was no water for hydration. So excessive suction is one problem. And the second problem with vacuum dewatering is, when the water is sucked, it makes pathways from the bottom of the concrete to the top of the concrete. We'll have beautiful pathways. At a later date, especially if it's a grade slab, rising moisture, it can happen. And very risky, we should not attempt dewatering. It is not required. Ready-mix concrete plant, they supply concrete at a water cement ratio of 0.43, 0.44, 0.45 kind of thing. No need for dewatering, vacuum dewatering. It is one operation wasted. Nowadays everybody gets concrete from RMC plant. All that one has to ensure is, you make concrete with a water cement ratio of less than 0.45. Usually it will be there. No need for dewatering, and it's dangerous for the concrete. Okay, please. Even recently, very recently also, one of the factories, somebody had installed the epoxy floor, and they had done vacuum dewatering. Everywhere they had done properly, but one particular part of the floor, it was excessively dewatered, and it had caused water path. Heavy rains were there, water started coming up, huge blisters formed in one of the industries. So be careful about vacuum dewatering. Then dry shake hardener. Whenever we lay concrete, however well we make, there will be some bleed water. So when concrete bleed water is there, the top layer of the concrete will have a high water cement ratio. What is high water cement ratio for us? Low strength. So it's weak and it gets worn out very quickly. That's why dry shake hardener came into picture. When the concrete is still green, when the bleed water had just evaporated, you just sprinkle it and float it. The dry shake hardener contains cement, some chemicals and some aggregates. And these aggregates, it can be corundum, it can be these quartz, or different types of aggregates are there. Each will have different hardness, and based on the kind of aggregate, it will give you that level of abrasion resistance. Number one, what happens is, the water cement ratio that has gone up due to bleed water, that bleed water will be utilized by the cement in the dry shake hardener, and the hard aggregates will give you abrasion resistance. So, a two-way attack, it will make the concrete more abrasion resistant. That is a dry shake hardener. And actually it started with corundum. You would all be familiar with the Mohs scale of hardness, 1 to 10. 10 is a diamond. 10 or 11 I think is diamond. That is the hardest material. then comes corundum, then comes something else. Lowest, weakest material is number 1, which is talc. So we should check what is the aggregate, that is, what kind of aggregate they have used, what is the hardness of it, and what kind of load. Okay. And it's very easy. It's a very crude way it's being done, but still it is quite, with a skilled hand it is effective, by hand sprinkling and then troweling. This is the dry shake corner. The next cementitious floor topping material, we talked about dry shake, and then of course this is also cementitious concrete, only some fibers to improve the concrete properties. Then there is one very interesting product called metallic aggregated screed. It's a screed. It's about 15-20 mm thick. It can be installed both on the green concrete as well as on a old concrete. What does it do? It is extremely abrasion and impact resistant. It is very high abrasion resistant, very high impact resistant. In fact, it has been used for earth moving equipment on the test bed. You know, that with a traction kind of thing, you know, for its traction, when it takes a turn and all that, it makes lot of abrasion, but it is used there. It is used on the spillway of the dam. Why? Because in the spillway, when the water is flowing, it carries some boulders and all that. It keeps falling, that impact is absorbed. It is a cementitious material. And I don't want to make this product Anamika, because only one company produces in the world this particular product. This is called Master Top 300. Originally MBT, now it has become a part of CEBACA. So it is Master Top 300 because they are the only people making, so I am giving the product name. It was developed in 1902. This was used for the first Ford automobile plant for the floor. And you know something, just it was 1912, it was used in the Ford automobile plant. Now it is what, 2023. In 2011, our engineers went and measured the wear out on the concrete, okay, with a straight edge. It had worn out at some points maximum 2 mm, 1.5 mm, 2 mm. After nearly almost 90 years. That is the kind of product. And it has been used many places, even in India, in steel plants. I mentioned to you know, in that Rourkela steel plant, the tires were going away. They are spending 17 lakhs per tire, imported tire. So on that floor it has been used. They are very happy. It has been used in JSW steel. It has been both Ballari and Goa. It has been used in umpteen number of, it's a very unique product. It's a niche product where you have got very high abrasion or very high impact. This is a product to be used. It's a one-time installation. Mr. Srinivas was talking about sustainability in the morning. We need to leave resources for our future generations. So this is one way. Use the right system which can last long, so that again and again we don't have to use this kind of material. So this is another cement-based floor topping. And then we move on to polymers. Polymers complement concrete floor. Whatever deficiencies are there in concrete floor, polymer takes care of it. Now, what are the deficiencies we identified? We said weaknesses of concrete. It is susceptible to chemical damage. One of the most common chemicals, it is bound to get damaged, is anything acidic. if you have got exposed concrete in your houses or anywhere, just squeeze a little lemon on that. The lemon juice contains citric acid. It's an organic acid, very weak acid, but it will damage the concrete. You will see the reaction on the concrete when you squeeze lemon juice. So like this, it is very, very reactive with acids, and acids can be broadly classified into organic acids and inorganic acids. Organic acids are all coming from plant and animals and plants. Inorganic acids they are called mineral acids, like hydrochloric acid, sulfuric acid, nitric acid, phosphoric acid. These are all mineral acids. These are all inorganic acids. But organic acids are citric acid, malic acid, tartaric acid in tamarind, like this. If this area, there are a lot of dairies. If anybody giving any service to dairies are here, you will be interested to know that lactic acid, it comes from milk. Milk, when it curdles, it forms lactic acid, very corrosive to concrete. Now, chemical resistance is one of the things that is taken care of by polymer floorings. Now, for a long time, it was only epoxy was the first polymer which came into the use of civil engineering for flooring, for whatever. Now, at that time, it was thought that epoxy is highly chemical resistant, but it is not. It can withstand maximum 10% hydrochloric acid, maximum 5% concentration sulfuric acid. Okay, it cannot withstand any nitric acid. It's about the mineral acids. Organic acids, it cannot withstand any organic acid. It cannot withstand lactic acid from milk dairies. Acetic acid, that is vinegar, citric acid, all the citrus fruits. It cannot withstand organic acids. So, epoxy cannot work wherever you have got this kind of situation. In chicken processing plants, in meat processing plants, kind of thing, there will be lot of spills of blood and tissues and all that on the floor. All these contain amino acids, the proteins, building blocks, amino acids. These amino acids eat away the concrete. Okay, it will eat away the concrete means I am not saying 100 mm thick concrete will become 50 mm. No. Gradually surface gets eaten away. But what is a bigger damage is whenever concrete surface gets pitted because of the bacterial acid action, bacteria will grow in that. It becomes unhygienic. That's why if you go to any dairy plant, most of the dairy plant, ice cream plants, you cannot step inside and stay for long because it stinks. Because the floor has got bacteria there. One of my bad friends, he wanted to teach a lesson to our English lecturer. His old car, he opened the window. Through that, he puts a little curd below the seat. And that curd would have smelled like anything after 2 days. He could not use the car. He didn't know where the smell is coming from. See? So, that is because of bacterial action. So, as far as the chemical action is concerned, when it comes to acid, this epoxy is, it can withstand mild acid. I know, I that's why I continued. So it's purely audio, no video, no audio, no visual. Okay, please bear with me. The next is whenever you got now, what are the different polymers used in flooring? Number one is epoxy. As I told you, it's the oldest. Invented by CEBACA. They held a patent for a long time. And then polyurethane. You would have heard of the names like polyurethane. Polyurethane was invented by Bayer. Dr. Otto Bayer got Nobel Prize for this invention, chemistry Nobel Prize. Polyurethane, epoxy. Then there is a composite, Imperial Chemical Industries, England, the paint company. They were using many very horrible chemicals. So their floor was getting damaged, whatever they did. They used epoxy, polyurethane, it was all getting damaged. So they set up a research amongst their own chemists to find a chemical which can withstand all this, find a floor topping, a resin system which can withstand all these chemicals, abrasion and impact. So they cooked up a resin system, okay, which was used in ICI, that is Imperial Chemical Industries, Britain, in all their plants. And then they didn't have any use for that. They sold the technology to Master Builders Technology at the time. They bought it. It goes with the name Eucrit. This is a third type of polymer you got. But the third type of polymer is the only polymer designed only for floors. Whereas epoxy is designed for many things, polyurethane is designed for many things. Now, what is the difference between epoxy and polyurethane? I am talking in terms of performance. In terms of performance, both are almost identical in terms of chemical resistance. Both are almost identical in terms of abrasion resistance. The only difference is epoxy is very brittle in nature. So supposing something drops, it cracks, and then it will flake off like poppet. You would have noticed somewhere. Polyurethane will not crack. PU will not crack. It will not come away. So this is one difference. The second difference is epoxy is very glossy, sometimes too glossy, strains the eye. But whereas polyurethane is matte, both come in many colors. So this is the difference between epoxy and polyurethane. If given an opportunity, you want to use that kind of a material which has got low chemical resistance and all that, a PU floor is superior to epoxy floor. Okay, some of you may say that we have come across epoxy floors which has been lasting for 15 years. Possible. Why? Because there's a very interesting thing. Epoxy is produced with a resin called epichlorohydrin. It contains chlorine, very high amount of chlorine. The inventors of epoxy, CEBACA, they used to do a process called dechlorination. They used to remove the chlorine from the resin. And when the chlorine is removed, the material that you get is a little more flexible, not so brittle. But dechlorination is an expensive process. As long as CEBACA produced epoxy resins, this dechlorination was happening, and you used to get a good resin system which was not cracking easily. But then after the patent was over, everybody manufactures epoxy resins, South India Polymers, people from Taiwan and Thailand and all these people, they are not bothered about dechlorination. They supply with chlorine in that, which makes it very brittle. Epoxy has become very brittle because of the chlorine present in that. In any case, net result as far as we are concerned, not the chemistry part of it, epoxy is brittle, it cracks. Polyurethane is not brittle, it does not crack. It is much more long lasting, much more durable. Now, one is chemical resistance. After epoxy and polyurethane, I mentioned to you about that polyurethane, polyurea hybrid resin system with cement, that is Eucrit. Now there are many companies also producing that kind of material. That is amazing. That is the only polymer floor even now working even after 40 years, 50 years. Even after 40 years, still performing. So this is highly resistant to organic chemicals, organic acids, inorganic acids, solvents, all these. So this is about chemical resistance. The other thing about polymer systems, what it can do is it is used to protect the concrete from chemicals. They are used to protect products produced, stored on the floor in the industry. I'll give you an example. All the electronic components, the PCB of the watch, phone or whatever, they are susceptible to damage by static electricity. When people walk on the floor, we generate a static electricity of something like about 12,000 volts, the voltage difference. And a spark will jump from our finger to the components and it gets damaged. We cannot even see the damage because components are so small we cannot see. It gets rejected. There was a classic case wherein one of the chip manufacturing factory in Taiwan, from the pantry, the lady came and kept the tray of tea, and she was going. There was to the QC. There was a tray of chips to be QC'd. She just pushed it, and the spark has jumped, and all the batches, they were all got damaged. No, they rejected all the batches. They lost nearly about $1 million, Hong Kong dollars, Taiwan dollars worth of material because the spark jumped. You cannot see the spark, but it jumps. Now this, wherever you have got electronic industries, wherever you have hospitals with sensitive equipment, where it records ICU and all that, those places you need to have this kind of floor which will resist, which is conductive floor. So polymer floors can be conductive floors, ESD, electrostatic dissipation floors. The same way, other places where they store explosives, TNT or dynamite or whatever, highly inflammable material like petrol, like diesel and all that. There also you need this kind of conductive floors, because any spark jumps, the whole thing can go in flames. So this is polymer floors to protect the materials kept in the premises. And lastly, polymer floors to protect people. Can you imagine? How many, we all know old people, say 80 years old or whatever, they usually slip and fall in a bathroom or in the hall, and that is the beginning of their end. Normally they break something and they will never recover. And am I right or wrong? At least many of my relatives have passed away, my friends' relatives. Now, because this slipperiness in the floor, on the tile floor, it happens. There is a kind of polyurethane floor which is soft. Soft, because it is soft, it is not slippery. As simple as that. It is like wearing a rubber shoe. So this is used in old age homes, geriatric homes, hospitals, because when a nurse walks in the ward, that shoe sound will not come. The patients will not wake up from the sleep. Children's play area, schools, these kind of soft floors are used. They are called comfort floors. And you can design the floor colors. If there are any architects here, you may note, you can design the colors of the floor, how it should be, and it can be made. Not one color, you can have multiple color floors, multiple design. In any case, polymer floors can help you in protecting the concrete from chemicals, protecting the materials stored in the premises from damage, from static electricity, protecting the people from slips and falls. Thank you.